These are the topics presented in this video. Follow along as we describe each.
Topic 1. Lights out manufacturing. So what is it? This is an automated manufacturing process where factories actually aim to be entirely or at least almost entirely autonomous and without any or at least with very minimal human intervention. And ideally, there actually would be no human workers on site at all, and it could operate around the clock. Examples of companies with dark factories include Fanuc, which has many factories worldwide which are fully autonomous. They create industrial robots and CNC machines. As well, Amazon, an e-commerce company, which uses a hybrid approach, but is not fully autonomous yet. And Tesla, for the future, wants to create a fully autonomous vehicle factory. So what do I like about this? Well, for one, high-quality robots are increasingly going down in price at around 10% per year, which will make them more desirable and accessible, so more companies will use them. As well, the precision of these machines will allow for more freedom in design. In terms of creating the product, these such factories allow for repeatability and facilitate mass production due to their increased accuracy and precision. There are some limitations involved, such as setup with high costs and lots of time, as well monitoring requirements to ensure that everything is working well, and the current cost of autonomous machines and robots is relatively high. For capabilities, the lack of humans on site does mean reduced labor costs, less accidents, and production rates increase since there's 24/7 operation, and autonomous machinery allows for decreased error, which leads to reduced waste. As well, the precision of robots means increased quality and speeds and increased repeatability. Minimum viable product. This is a lean startup process used in the learning stages of new product development, where the MVP is some version of a new product, allowing for the maximum collection of data while taking the least amount of effort. However, the product must be some sort of actual product created for customers to react to, but could be simply a website. Then you can directly observe the reactions of customers and use that to be able to improve future iterations based on the response. Examples of products created using MVP are shown below, where Amazon and Facebook both created an initial website as an MVP, while Airbnb used an ad and Dropbox used a simple video to gain traction from investors. So what's to like? So this is a method of lean startup which prioritizes gain over effort, eliminating time waste, as well as potential costs. And there is minimized effort for the initial response. Companies are able as well to scrap failed products at an earlier time than what would usually be done. This concept also helps for designing and manufacturing better products because companies are able to observe reactions directly from customers and then adjust early on in the product process, which allows for a better final product. So the main limitations actually lie in over-focusing on the lowest effort and overlooking the viability of the product. As for the capabilities, you can gain lots of insight from the customer base, and since this is a lean production method, there is low effort and low cost involved.
Carnot model. This is the Carnot model diagram. Let's take a closer look at it. Some examples of a linear relationship or a proportional relationship between these axes is gas mileage, internet connection, and laptop battery life. Some examples of an indifferent relationship, something that users don't care about at all, is the color of an internal wiring system, or the font in an email confirmation, or even the thickness of cardboard when packing a non-fragile item. Basic expectations are when users must have these products and will only be dissatisfied if they're not present. For example, a phone to make phone calls. Nothing to be delighted about, just upset if it doesn't work. Or a car to have brakes, or a hotel room to have a bed. On the flip side, attracted delighters only delight the customer if they exist, like ChatGPT, that was super exciting, or Google Maps when it was first used, or the touchscreen when it first came out. And then they all come together to create this diagram on the left. Tesla is a good example where they keep all this in mind. The Carnot model appeals to us because it goes beyond functionality, emphasizing on customer emotion. It encourages innovation and ensures that businesses constantly evolve, allowing them to stay relevant. The Carnot model results in better products because manufacturers can apply it to identify which basic needs are critical for market entry, enhance performance in a way to justify pricing, and innovate exciting features to differentiate from competitors. Some capabilities are that it categorizes features based on customer satisfaction. This ensures that time and money spent are impactful. It also identifies features that stand out from competitors and can constantly be adapted with customers' evolving needs. Some limitations, however, are that it doesn't account for the actual feasibility of the product. And since not all features of a product fit into one category, things can get complicated. It also relies heavily on very subjective customer feedback, and it prioritizes immediate customer satisfaction over long-term market strategy.
Past and future plastics in product development. Plastics are polymers with various properties. The first patent for a synthetic plastic actually came about in 1909, where plastic replaced ivory in keyboard keys and more. It began to be used for electronics for its insulating and non-melting properties. Until then, these were generally thermosets, which are rigid and don't melt. As well, they can't be recycled. In the 1920s, thermoplastics were created, such as PVC. These are recyclable and moldable plastics. Now, in the future, it is expected to see increased production of plastics and as well alternatives to fossil fuel-derived plastics. So what's to like? Well, for design purposes, plastic can be used in 3D printing as filament for rapid prototyping, and it is versatile due to being durable and lightweight. Also, I look forward to improvements in environmental concerns and more plastics being created through recycled methods. For creating better products, plastic allows for versatility in shapes and a wide range of applications due to varying properties. Plastics are also cost-effective and suitable for mass production. Limitations for plastics mainly involve environmental concerns, such as increased waste and pollution since they are non-biodegradable. As well, thermosets are not recyclable. Also, there are safety concerns due to microplastics harming biological organisms, and lastly, greenhouse gas emissions from creating the plastics. For the capabilities, plastics allow for rapid prototyping, as well thermoplastics are recyclable. Low-cost products are created, which are lightweight and durable. Retrofitting. This is the rebuilding and modification of a machine. Machines are upgraded by adding new technologies and/or features to improve the overall performance. This is because machines are created for a long lifespan, usually decades, but manufacturing technologies often change within a short amount of time. Machine retrofits adapt to these new technologies without having to purchase a whole new product. CNC retrofits are one common method of either adding or updating a machine with a new CNC, which is a computer numerical control. Here in the picture is a photo of a centralist grinder converted from manual to having a CNC. Industry 4.0 is the integration of intelligent digital technologies in industrial processes. Emerging technologies encourage the use of retrofits. However, companies must be aware of changing technologies and standards when retrofitting. So what do I like about this? The life of manufacturing equipment is extended, all the while keeping up with changes in industry. As for creating better products, the quality of the final product is improved as technologies with more accuracy and precision are incorporated. In CNC retrofitting, less room for human error exists. Some limitations include the design of the original machine limits what can be added. As well, for maintenance, there's a struggle to find replacement parts and a potential void of warranty when altering the machines. For capabilities, there's an increased machine performance and increased lifespan, which maximize the return of investment of the machine. As well, waste is reduced and cost, and time is saved to set up and implement as opposed to new machinery. Eliminating muda. This is a Japanese concept in lean practices, referring to waste and generally anything that does not add value. There are generally considered to be 7 types, which are overproduction, inventory, waiting, transportation, motion, defects, and overprocessing. Eliminating muda is a goal of lean manufacturing, which adds to customer value. Lean manufacturing is a concept originating from Toyota as the Toyota production system. It aims to improve efficiency and minimize waste and anything not adding value. This optimizes production. What's to like about eliminating muda? This adds to customer value and increases customer satisfaction, as well manufacturing becomes more efficient. Eliminating muda also helps in creating better products because the quality of products increases and defects are identified and addressed early on, rather than later. As well, increased customer value results in more sales. There are a couple limitations involved, mainly small room for error. If equipment fails, there are either no or very few backups, so also maintenance is very important. Less inventory also means that delivery inconsistencies can be detrimental to manufacturing processes. As for capabilities, there's minimization of waste, cost, and space necessary, so production efficiency increases and customer value is enhanced.
Augmented reality. Let's look at a quick summary of AR. 1. It allows for prototyping before committing to production. 2. It can guide you through an assembly process. 3. It allows you to practice without physical risks. And 4. You can use it to see internal systems without disassembly. Traditionally, technicians had to construct an image in their mind and wire based off that. By using AR, that's unnecessary. Boeing says there was a 90% improvement in first-time quality, along with a 30% reduction in time spent. AR excites us because it streamlines these complex processes, reduces human error, and has a high degree of precision. We also love that it makes learning and troubleshooting intuitive. This would of course save both time and resources. AR enhances the product development by enabling rapid iteration and collaboration. Imagine designing a car where stakeholders can just walk around and interact with the model in real time. It also obviously makes it much safer. Now for the capabilities. It minimizes human error, allows for quick iteration and redesigns. Plus, it provides hands-on training in a risk-free environment and fosters global collaboration remotely. For limitations, however, it does cost a lot to start up, and it requires training employees. Plus, it needs tablets or some other device which might limit accessibility. And of course, it's very highly dependent on the quality of the digital model. Value stream mapping. So this tool visualizes the flow of processes to deliver a product. This identifies waste, optimizes workflow by mapping every single step of the process, obviously improves communication, and encourages these continuous iterative improvements. This is famously used by Toyota. They meticulously map out the steps of their production process to eliminate any non-value added activities. They realized they had excessive inventory storage and unnecessary transportation, and they were able to reduce waste, resulting in a lot faster production cycles. We love VSM because it makes abstract processes visible. It does this by simplifying complex workflows and giving actionable insights. It also focuses on continuous improvements and empowers teams to focus on delivering maximum value with minimal waste. This also results in better products because of the reduction in lead times, improvement in product quality because this reveals redundant or error-prone steps, and it's sustainable because it minimizes resources wasted. Capabilities are that it provides a clear map of end-to-end workflows. It also unifies teams around a shared understanding of process improvements, and it's applicable to diverse fields. Additionally, it drives waste reduction, resource efficiency, and just overall a better productivity. However, the limitations are that it takes time to map these out, and it requires expert analysts. Plus, it's not a dynamic model, just a snapshot of the present moment. Impact on manufacturing on the US economy. Manufacturing is the cornerstone of the US economy. It employs millions of people, drives up the US GDP, ensures that the US is a global trade leader as well as a global technological innovator. Companies like Ford and Boeing are particularly impactful to the US economy. We like this because manufacturing shapes the backbone of technological and economic progress. Its ripple effects extend across industries, improving quality of life and driving innovation. Understanding the broader impacts result in better products because it allows us to focus on practices to minimize environmental impact and innovate automation systems for efficiency. Additionally, prioritizing local manufacturing can create jobs and reduce supply chain risks. Capabilities are that it strengthens the economy by creating jobs and allows the US to remain globally competitive. It also drives great technological advancements through R&D, but especially could promote sustainable practices. However, the limitations are that it does contribute significantly to pollution and resource depletion. Automation could also reduce job availability, plus there's a lot of other countries with lower manufacturing costs. And we're at risk for supply chain disruptions as seen during the pandemic. Digital twins. A digital twin is a physical product, process, or system. It allows us to test initial designs during development, and any wear and tear maintenance on machinery can be proactive. They can also be tailored to different fields, and all processes can be simulated to be optimized. So one big application is Nissan using digital twins to boost powertrain production for their electric Leaf car. By simulating bottlenecks, they identified storage loop modifications that doubled production rates while still maintaining quality. We love the concept of digital twins because they bridge the physical and the digital worlds. They help reduce costs, improve safety, and accelerate innovation. They can also predict outcomes and improve decision making in real time. This results in better products because there's rapid innovation. Multiple designs can be iterated as physical prototypes are unnecessary. Manufacturing processes can also be optimized to the max, and we can predict and resolve product failures before they actually take place. Let's look at the capabilities. It provides immediate insights into the system's performance. It also eliminates excessive physical prototyping, cutting costs. Plus, it helps make business decisions by simulating different scenarios, and it can be scaled from one product to a whole facility. Now for the limitations. It does require quite a lot of extensive high-quality data, and it is very complex to actually implement. Additionally, as a digital system, it's vulnerable to data breaches or hacking. As a result, it can be quite expensive initially.